Hello friends, today I am going to talk about conditional structures. That means these are such statements in Java which is used to provide a condition. That means a program is able to take decisions. So to take decisions, we use conditional structures in Java. One of the basic forms of giving condition in Java is the if statement. It looks something like this: if, and within parentheses you provide with a condition. I'm going to talk about it later. Then the statements to be executed if the condition is true. Else, which is optional, in case you have a statement or a group of statements which you need to execute if the condition is not true, we use the else statement. Now note that else part of the if is an optional statement. That means in case we have a statement or a group of statements to be executed if the condition is not true, only then we use the else block. Otherwise we can simply skip this else block. We can do away with if block. Now how do we provide with a condition? We provide condition using a technique something like this. If A is a variable, say greater than 50, we can print a message system.out.println greater than 50. Else we can write system.out.println not greater than 50. Now here what the computer does is it initially checks whether the value of A is greater than 50 or not. If it happens to be greater than 50, it gives a message greater than 50. Otherwise it jumps to the else part and here it prints the message not greater than 50. So such simple operations can be done to make a program take decisions on its own. Now this greater than symbol which you see out here, which we also use in mathematics, is called a relational operator in Java. Few relational operators which we use in Java are greater than, which you have already seen in action, less than, greater than or equal to, which in mathematics we use it as something like this. We use a symbol, and then similarly less than or equal to, that means either less than or equal to. Equal to is written twice to differentiate between the equal which we had learned earlier for assigning a value to a variable, and then we have not equal to. In mathematics we write it something like this. In case we want to check for a certain condition, if it is not fulfilled, we use this not equal to. Now these are the set of 6 relational operators which we are going to use while using the if-else statement. One point to be noted: in case there is only one statement to be executed for the condition to be true, or similarly if there is only one statement to be executed for the else statement to be executed, if there is only one statement inside this block, giving braces is optional. That means in this case I could have written the entire if-else statement without the braces. I could have just written, if this condition is true, it will print this message, otherwise it will print this message. Now this way, without giving the braces, is applicable only when there is only one statement within the if block, or there is one statement within the else block. Say for example, I have to perform a certain calculations. I have to perform a certain calculation that involves a condition. Say for example, I need to do something like this: a plus b, where all these are variables, d equal to a into b. Now this time you cannot leave it just like that. You have to put the braces to indicate that if this condition is true, two statements are to be executed. That means A and B should be added and stored inside C, and A and B should be multiplied and stored inside D. So there are two statements to be executed if this condition is true. So we need to put braces. The same thing occurs with the else also. If there is more than one statement to be executed, you have to put the braces for the else. Otherwise, you can just leave it if there is only a single statement. Now, let us look at an example that involves conditional structures, if-else. In this particular program, which we are going to discuss, I take two integers as input and then find their sum and check whether their sum is greater than 100 or not. So here, to keep things simple, we have taken parameterized input A and B. Two integers are to be entered by the user. I've taken a third variable C where I store the sum of these two variables A and B. So these two values gets added and gets stored in C. Now I check whether the value that is stored, that is the sum, happens to be greater than 100 or not. If it happens to be greater than 100, then the computer gives the message greater than 100. In case it is not greater than 100, if it is equal to 100 or less than 100, it will give a message not greater than 100. Note that I haven't given the braces because there was only one statement to be executed both in if as well as else. In case the condition gets true or gets false, therefore I did not put the braces. Now let us try another program that will involve checking whether a given number is an even or an odd number. Now let us, before getting into the details of this program, let us try to understand what is an even or an odd number. A number is said to be even if it is divisible by 2, which means that when you divide a number by 2, its remainder happens to be 0. So here what we are going to do is we are going to make the computer check the number when it is divided by 2, its remainder happens to be 0 or not. If its remainder happens to be 0, we can tell that the number is even, otherwise we'll tell that the number is odd. So here I have taken a number as input, you can see over here, a parameterized input, and here I am checking whether the number is even or not. Now look at this statement, A modulus 2. Now remember the modulus operator which I had talked about. It's a mathematical operator which divides a number and finds its remainder. So the modulus operator is used to find the remainder. So when A is divided by 2 and if its remainder happens to be 0, we can tell that the number is even, and if the remainder is not 0, we can tell definitely the number is odd. We talk about another set of operators which we use with conditional structures in Java, that is called the logical operators. Logical operators are used to join more than one relational operations, which we had seen earlier while using the relational operators. So there are three types of logical operators, namely AND, OR and NOT. Both the symbols are written twice, ampersand symbol to represent AND, pipe in symbol to represent OR, and NOT only represented by a single exclamation mark. Now what these three logical operators does, we are going to understand this with the help of an example. First, when it comes to the AND logical operator, this is generally used with multiple relational operations, and it is used to make Java understand only when all the conditions are true, then all the statements in the if block gets executed. Otherwise, the statements in the else block gets executed. I'll give you an example. Suppose if it is written out here, if A is greater than 50 and B is greater than 50, then certain statements to be executed in the if block. Otherwise, there are certain statements to be executed in the else block. Now you see, the logical operator AND is used to join more than one relational operations. That is, to join more than one comparisons. What it does is, only when the value of A and B are both greater than 50, that means this condition is true as well as this condition is true, only then the statements in the if block gets executed. Otherwise, the statements in the else block gets executed. When it comes to OR, either of the conditions, if I put an OR out here, the logical operator OR, So either this condition or both the conditions are true, only then the statements in the if block gets executed. The statements in the else block gets executed only when both happens to be not true. Now not is very peculiar. Not is basically used to negate a logic. This is generally used to check whether a condition is not true. Now it might sound peculiar, but sometimes it is quite useful. Say for example, if I write a statement something like this: if not a greater than 50. If not a greater than 50. Look at the way it should be given, not followed by within the parenthesis the condition. That means if it is not that a is greater than 50, in other words, if a is less than or equal to 50, no doubt regarding it, if it is not that a is greater than 50, only then the statements in the if block gets executed, otherwise the statements in the else block gets executed. Now we are going to see the usage of the logical operator. Okay. Now we are going to see the usage of the logical operator. This particular program which I am going to discuss, it is used to check whether a number is two-digit number or not. Now let us try to understand this particular problem. What is a two-digit number? A number is said to be two-digit if it lies between 10 to 99, both inclusive. So here we have two conditions. One is the value of that particular number should be either greater than or equal to 10, as well as it should be less than or equal to 99. So this is what I am doing. I am taking a number as input, a parameter as input into the variable a, and then look at the way I am checking whether the number is a two-digit number. If a is greater than or equal to 10 and followed by the logical operator, that means both the conditions should be true. A is less than or equal to 99. So that means it lies between the range of 10 to 99, both inclusive. If it lies between that, we can display two-digit number, otherwise we can display not a two-digit number. So if the value of a is 153, so the condition is not fulfilled. It may be greater than 10, but it is not less than 99 because both the conditions should be true. So it jumps to the else part and gives this message, not a two-digit number. The current program which we are going to discuss is a bit peculiar. What I want is, I want a number to be entered by the user, that is take a user input and check whether it is a 5-digit number or not. It sounds simple, but after that comes the real thing. If it is a 5-digit number, we are supposed to extract the middle digit of that 5-digit number and display it on the screen. And if it is not a 5-digit number, it should display an appropriate message. Now look at this. For example, suppose if I input 45376, so the output should be 3 because that happens to be the middle digit. Similarly, if I input 78135, in that case the middle digit is 1, it should display 1. So the middle digit depends upon the user input, whatever the value the user inputs. And if it is not at all a 5-digit number, it shouldn't be printing any middle digit, it should print that it is not a 5-digit number. Now let us try to understand this particular program, how I am able to do it. What we do is, we take a number as input. I have taken one more variable b, where I am going to store the middle digit, provided the number is a 5-digit number. So the first thing what we need to do is, we need to check whether the number is a 5-digit number or not. How do we do that? We check whether the number is either greater than or equal to 10,000 and less than or equal to 99,999. So if it is, that means it's a 5-digit number, no doubt regarding it. Now look at this next statement. B equal to A/100, written within parenthesis, it should be executed first, modulus 10. Now what on earth it is doing? Let's try to understand. Let me take a random number as an example. 76349. If this is the 5-digit number, so suppose this is the value. Now what is written over there? B equal to A by 100. So 76349, when I divide by 100, what we are going to get is we are going to get 763 because that is how integer division works. Remember, we did not typecast it as float, so therefore there is no question of getting the answer in decimal point. So what we get is, we get 763. Now this modulus 10 will give us 3. Any number divided by 10, its last digit is always the remainder. So we get 3, which happens to be the middle digit. So this is written as a single statement. This entire thing, which results to 763, modulus 10 will give you 3. So this is what happened. B equal to A/100, which gave you the first 3 digits of that number. Modulus 10 will give you the last digit of that 3-digit number. So it happens to be the middle digit. So, and here what I am doing is I am printing the middle digit. And if it happens to be not a 5-digit number, it prints not a 5-digit number. Now note that since there are 2 statements to be executed, if the condition is true, we enclose this within braces. And in the else, there is just 1 statement to be executed. So therefore giving braces is optional. So I have just left it out. Now this type of questions are quite common. That is, if it is a 5-digit number, display the middle digit. If it is a 7-digit number, display the middle digit. Oh, why only the middle digit? It may be the second digit. Say for example, we are supposed to check whether a number is a 5-digit number, and if it is a 5-digit number, we are supposed to print the middle digit. So what is the trick? What we are going to do is, we are going to ensure that we get only this part of the number. Out of this 5-digit, we'll ensure, since we want the second digit, that is 6, what we are going to ensure is, we are going to extract only this part of the number. Why this part of the number? Once I get this part of the number, that is 76, when I write modulus 10, it always gives me the last digit. Now look at this. After this, how many digits are there? 3 digits are there. So what we are going to do is, we are going to divide the number by 1000, so that we get the first 2 digits. Now this, on giving modulus 10, what gets stored inside B? B will get the value 6. A modulus 1000 is going to give you 76. 76 modulus 10 will give you 6, which happens to be the second digit. Now similarly, say for example, I am supposed to print the second last digit of a 7-digit number. Let's try to understand how do we do it. Suppose, say for example, we take a 7-digit number. Let me randomly write a number. So this is a 7-digit number, and I want to extract the second last digit of that number. So what we are going to do is, we are going to first extract this part of the number. So to extract this part of the number, so suppose, say for example, this is A. So how do we do? Divide by how many digits are after that? 1 digit. So we are going to divide it by 10. So what we are going to get? 7, 6, 3, 4, 5, 6. Now this, on modulus 10, it is going to give you 6, which happens to be the second last digit. This is how the entire thing works. Now, there is one more type of conditional structures, just like if-else, which is generally used when we have a condition even for the else part. That means, if a condition is true, it executes a certain group of statements. If the condition is not true, this might lead to another condition, which again, if it is not true, might lead to another condition. So there may be several such conditions in the else statement. So in such situations, we use the if-else-if block. It has the following structure. If the condition is true, it executes whatever is out here. Else if the condition is true, else, again we have an if. It executes this group of statement. If this condition is also not true, again else if, again it checks. This process can continue for several lines until we have the else block. Else block means if none of these conditions are true, the statements in the else block gets executed. Now, one unique feature of this if-else if block is, if a particular condition gets true in this, it simply exits from this block altogether. no longer it's going to see the remaining. Suppose, say for example, the condition out here gets satisfied. So what happens is it first checks whether this condition is true. Since this condition is not true, it will check over here. Now if this condition is true, it simply exits from this entire if-else structure, if-else-if structure, and goes for the next statement. Whatever is written out there, it goes to the next statement. That means it exits from this entire structure. So that means in case you have multiple conditions to be checked and only one condition can be satisfied, in that case we can use this particular structure. Now this particular program is going to show you the usage of the if-else-if structure which I had discussed earlier. Now this program, what it does, it takes three numbers as input from the user and finds the largest among these three. So here what we do is we take three numbers as input, A, B and C. Now when can we tell A is the largest? If the value of A happens to be greater than B as well as greater than C, only then we can tell A is the largest. Similarly, suppose, say for example, if this condition is not true, that means if A is not largest, that means B may be largest. So that is why we need to again check whether the value of B is also greater than A as well as B is greater than C. We can tell B is largest. Now if neither A nor B is largest, that means definitely C is the largest. So therefore we did not put an if statement again with the else. We simply wrote else C is the largest number. So if the first condition is true, if A happens to be greater than B and A is greater than C, the remaining statements will not be checked. Similarly, if this condition is not true, only then you will check whether this condition is true. If this condition is true, the remaining statements will not be checked. So this will also increase the efficiency of the program in case we have a lot of if-else-if statements to be executed. Now we can have a nested if also in Java. Nested if means an if inside another if statement. For example, the program which I have written is we are supposed to input three angles of a triangle, check whether it forms a triangle or not. How do we check whether it forms a triangle? If the sum happens to be 180. So we are going to accept three angles of a triangle, check whether the sum is 180 or not. If its sum happens to be 180, we are supposed to check whether it is an acute angle triangle or not. Now, if you listen to this question carefully, first we have a condition whether it forms a triangle or not. We are supposed to accept three angles and then we are supposed to check whether it forms a triangle or not. If it forms a triangle, only then we are supposed to check whether it is an acute angle triangle or not. Now, let us see this, observe this particular program where first of all, what we are going to do is accept the three angles A, B, C. We have taken three integers representing the three angles of the triangle named as A, B and C. Now look at the first condition. If A plus B plus C, we are performing a mathematical calculation, that is, if this particular sum happens to be equal to 180. If it happens to be equal to 180, that means it forms a triangle. Now, if its sum is not 180, it directly skips this entire if block, jumps to the else part and it prints not a triangle. So this part gets over. Now, if it forms a triangle, that means if the sum is 180, what it goes on to check is whether every angle is less than 90 or not. If every angle is less than 90, naturally it must be an acute angle triangle. In that case, it prints an acute angle triangle. Otherwise, it prints not an acute angle triangle. But at least it forms a triangle, but it may not be an acute angle triangle. So here you can see we have an if statement inside another if statement. So here, only when this condition, that is if the sum happens to be 180, only then it goes on to check whether it forms an acute angle triangle or not. How does it check? It checks whether all the angles are less than 90 or not. And accordingly, it prints a message. And here, if the sum happens not to be 180, so this entire if block gets executed and the statement in the else block gets executed.